Good afternoon. Welcome, everybody. We are going to start as soon as you take a seat. Our friendly discussion about lunar sustainable exploration. And we have many things that we like to share with you. And so we will try to keep the time and a few minutes also for you to be able to ask any clarification, any question you may like to ask to our distinguished speakers. So without wasting any time, let me tell you that the reason why as Thales Alenia Space we wish to propose this conversation is because Moon is coming back again as a big picture in our agenda. It has always been in our hearts, but now is, on our desk for our daily life, professional life. And I will start by Jim. We have the privilege to have Jim from NASA with us. He will share in a few minutes what NASA is planning to do to develop further this lunar exploration architecture. Please, Jim, the floor is yours.
Thank you very much. Good afternoon. Thank you for being here. I'm not sure if my slides, you can keep it on the first one for a second. So I do want to thank you for allowing me to be here today and talk about NASA a little bit. Certainly great panel here, and we are on the cusp of our journey, right? And it starts for us, and I say us, it's all of us, and I'll talk some more about that here in a minute. It's the start of the journey back to the moon. And our focus and what you're really seeing here is what we are hoping for in the next 10 years. First, it starts with science. All of you that have had to listen to me talk multiple times, it is really about the science for us. That science focus, one of the primary reasons we're going back. I'll talk some more about that in a minute too. We have these objectives. Our objectives are really laying out the map of what we're going to do, what we want to do, and our deputy administrator will make some announcements about that tomorrow. It's important we establish a cadence of missions, that yearly cadence of missions to achieve the things that you see here in terms of crew size and duration on the surface. We have to get to longer stays. In order to practice for Mars, we need the longer stays. And that will drive what we do with science. That'll drive our systems, both on the surface and in orbit. But what's essential to it are partnerships. We have incredible partnerships today with folks on this stage, both international partnerships, domestic partnerships, industry, international agencies, agencies of specific countries. So that's absolutely essential. You can go to the next chart, please. So our architecture, which we have the initial missions defined for our architecture, we're working on that next step. We have our lunar architecture, our lunar program, which is Artemis. Then we have our overall Moon to Mars program, of which Artemis is one element. You see the categories here. We're about to demonstrate the first use of our crew transportation system with our flight test of Artemis 1. We need to move on to our habitation and life support. We're using systems on Orion in the Orion second flight to prove that out. The life support, we'll continue that on with our human lander for Artemis 3, and then everything we want to do on the surface. I talk though about we really are developing it. We are not going, if any of you heard me talk yesterday, it's not about flags and footprints for us this time. It's about all of us going together. We have an incredible Orion capsule that's been built by Lockheed Martin with Lisa. We have our European service module that is in line on the Artemis 1 vehicle, so it's truly a global effort. Go to the next one, please. And then this is an image of the Artemis base camp. Many of you have probably heard me say, I don't know what the base camp looks like. This is one version, one instantiation of it. We understand the elements that we do, the things we need to aggregate on the lunar surface, but there's still so much to understand. If we put it in one spot, that may cause a series of issues because of how hard it is to land at the South Pole with the lighting. So what we've done is identify the key elements that we need, and then how we position them is really important. And that's the things that'll start to come out of our architecture development that's going on right now, and the architecture concept review we have coming up later this year.
Thank you, Jim. And now I will ask Massimo Comparini to briefly introduce himself and share what in Thales Alenia Space, what we do every day for lunar exploration.
Thank you, Maria Antonietta. I'm Massimo Comparini. I'm the Deputy CEO of the company, and also Director of all the exploration, navigation, and observation. I think that, as Jim said, I mean, the new phase is to stay, is to work, is to live, and also to start from the moon for other destinations. So there is a lot of infrastructure, building blocks to think about to make all that possible. So I have just a super quick view of what we are doing. And as you remember, Jim, of course, in the frame of the international cooperation, what we are doing under the European Space Agency leading and an umbrella, what we are doing directly with US partners, industrial partners. And that's the picture of the gateway. We know what we are talking about. We know what is the purpose to have a logistic outpost and choose lunar orbit. And what we are doing is to feed the building, the design, building, and the construction of the International Habitat Pressurized Module, ESPRI, which is a service module including a pressurized element, and also the halo, the primary structure for halo. So let's say how to take benefit of our long-standing experience in the building of the International Space Station. Of course, we know that we have a number of technologies that need to evolve. A model that will be around the moon or on the moon is not exactly the model that it's built the International Space Station. We have a number of technologies. Here we just list all the building blocks that we are working on. So first element, how to design around the moon realize an infrastructure that will help this new phase. Second, of course, be on the surface. So how we can use these technologies to build up first element, first modules to hallow the presence on the planet of the man. And okay, this is just a sketch, but this is the discussion also in place. Again, at the international level, it could be the contribution of the Italian Space Agency in cooperation with NASA for the Artemis project. And of course, let's say our goal is to design this multi-purpose pressurized module as a surface element. Maybe a place to make science, maybe a place to live, but this is the goal, and this is the priority in our advanced studies that together with NASA we're doing now. And then, of course, if we are going to have a first infrastructure to work on the planet, and including, let's say, to be placed in multiple spots in the South Pole, means that we need also to know where we are and to communicate. So last but not least, and again, I think it's extremely important, the potential role of the European Space Agency on that. We're working on the architecture to communicate, and the so-called moonlight that has been Dave recalled yesterday in his speech. And of course, we need to understand, based on the requirements, based on the, let's say, the capability of the capacity of the network, which kind of infrastructure, which kind of platforms we need to deploy, and why not also some constellations around the planet, including a small and maybe a little bit more bulky satellite. We know that to secure robust communication from the planet to Earth, there are a number of architectures that are coming also from the past studies.
Thank you very much, Massimo, for sharing what our company does. And now I will ask Dave, what ESA is doing for Moon?
Good afternoon, everyone. Don't you find it completely extraordinary that we are a few days away from the launch of Artemis 1? I have to keep pinching myself to think that we are really now starting this new era of sustainable moon exploration. And through our program, the exploration program, I had 20 minutes yesterday to present the content of the program. How many people were in the audience yesterday when I presented the whole vision of exploration? A handful. Okay, fine. Maria Antoinetta, I only have 2 minutes and 30 seconds, so I'm not going to try and present all of it.
Yeah, I've been preparing with them this conversation, but they are going out of the time as we knew already. So please, Dave, keep talking.
We can start where we are, this incredible first step with Artemis 1 about to happen. And then also you can maybe look into the distant future and imagine where the end point is and work backwards to where we are today. So I deliberately put this picture up, not because this is a project that we're proposing to build in ESA, but it's a reflection on what a permanent scientific technology research institution on the moon might look like. Habitable modules protected by lunar regolith, 3D printed, to cover and protect the astronauts, growing, at least at a research level, crops on the moon, the process of extracting raw materials from the moon and using it to make exploration more sustainable. So it helps sometimes to have a long-term picture of where you're heading to. Next slide, please. It's great to have a vision, but then you've got to have some steps towards that, and that's what we're trying to do in our exploration vision, the Terra Novae vision of new worlds of discovery, commercialization, and returning benefits back to Earth. And so we're starting in our transportation with providing the service modules as part of the Artemis program, but we are proposing to our member states at the ministerial meeting in a matter of a few weeks a series of European large logistic landers that could give Europe an autonomous ability to land on the moon, but also to allow us to contribute more deeply to the longer-term exploration program. And it is kind of twinned with this idea of lunar communications and navigation services. We're starting right now. We have a first cooperation with NASA on a small satellite lunar pathfinder to provide a lunar comms. But navigation, I think, will be a game changer in terms of sustainable exploration. But it's not just that you need. You need power. You need the possibility of using that power to extract resources. We're doing work in that area. Stepwise scientific utilization. I always say the moon is a museum of 4.5 billion years of solar system history. We've barely scratched the surface. We've just been to the museum gift shop. Now we have to do the real sciences there. And all along the way, we're going to develop the crew capabilities, the skills, the operational technologies we need. And it's all built on partnerships, international partnerships, partnerships within Europe. Again, I'd like to pay tribute to our colleagues in the German Space Agency. We're working together to build a kind of hub of lunar research and technologies in Europe at the European Astronaut Centre, but also the partnerships with business that are also addressed here. Is that long enough?
Yeah, it's perfect. Just one more slide.
And then the one more slide is to show you the picture, the intermediate step of one or more of these European large logistic landers capable of precision landing anywhere on the surface of the moon in support of the next steps in lunar exploration, building on the gateway you see in orbit behind. Hopefully not that close to the surface.
Thank you very much, David. And now, Lisa, would you mind to share with us what Lockheed Martin is doing?
Sure, thank you. Thank you for having me, and thank you all for being here. At Lockheed Martin, I lead our commercial civil space organization, and we have the honor and privilege of building NASA's Orion spacecraft. Orion is an exploration class spacecraft that's going to take humans back to the moon and beyond, and we're super excited about the Artemis 1 launch coming up and what we're going to achieve there. If you go to the next chart. As we talk about lunar infrastructure, I'm really proud of the investments and the innovations that our company's making here. Similar to some of the comments that you've heard earlier, communications and navigation is a key element to the infrastructure that needs to be there. Mobility is a service we'd like to provide on the moon to be able to move things around the surface of the moon. Typically, we land in a very flat, not very interesting area, but if we want to perform science, we need to move to a more complicated area that you probably don't want to land on, so mobility will be critical there. And then what's also been mentioned is around power. Having power on the surface of the moon is critical in our infrastructure if we want to be able to use the resources that are on the moon as well. I think the key thing that is important, and you heard it from everyone, is this is not something that's going to happen with one individual, one company, one country. This is really a global endeavor, and I'm really excited to be a part of this panel.
Thank you. Thank you very much. And now I would like to ask, starting from Jim, why are we going back to the moon? Which are the expected benefits for humankind?
And so I kind of call out three. Number one, I call out, I don't know if it's the most practical, but it's the first time in my NASA career that we have transitioned presidential administrations and maintained the direction in our destination. And I've been around a long time. Yeah. So number one, that's very practical for me. I think it bodes very well, too, that we have the right partnerships. I think we're performing. We have hardware. In the past, it's harder to stop programs like that. The second is it's in NASA's, from a NASA perspective, I think in the other agencies, there's similar goal to really explore the universe, the secrets of the universe for the benefit of all. Yeah. I think that's what we should be doing. And the third is the science. I keep coming back to it. I feel like I should work in the science mission directorate at NASA because I talk about science all the time. We've learned so much about the moon and the resources that are available there, from when we crashed a vehicle into the moon years ago and watched the lunar regolith come up and see the water content in it. We have had our Sophia spacecraft image the moon, and we saw much more water content in it than we had seen before. So the resources are there as well. And then to David's point, I'm going to get this wrong. This is why I shouldn't work in the Science Mission Directorate. But the museum piece that David talks about, around the equator where the Apollo missions went from, the rocks are 3 billion years old. But in the southern regions, you can see things that are around 4 billion years old. So we're going back to those locations from the science perspective as well. Yeah.
Lisa, would you like to complement what Jim said?
Absolutely.
Which could be the benefit besides science?
I think I agree with all that Jim said. I think another reason we go to explore is just that's what we do as humankind, right? We're always interested in where different roads lead or paths might lead. And so continuing to explore farther and farther into our solar system, I think, is just who we are. Another real benefit is inspiration, right? Human spaceflight is an inspiration to the next generation, the Artemis generation in this case, and really trying to inspire the next generation to be involved more in science, technology, engineering, math, I think is a great piece of that. And then there's technologies. There's technologies that we need to develop and innovate on to have humans survive in space that can then benefit us back here on Earth. And I think we've demonstrated that time and time again. And some of the same resources that we need to see if we have to be able to sustain life are resources that are maybe somewhat limited here on Earth. And so finding ways to filter water could help us here on Earth as well.
Totally agree. So we heard from all the panelists that, in fact, there is no one single actor that can, face lunar exploration in an autonomous way. So for sure, we need to progress according to an open type of architecture. So Jim, if I ask you, let's try to build together this architecture here in front of our colleagues. Which would be the first building block that you would put on the lunar surface right now?
Well, I think it'd probably be some type of rover. Because I think if you're asking me what I put on there first is that assumes we're down there. And we certainly have a path there with what we're doing with Artemis 1, 2, and 3. And then we need to explore. Again, I learned from our mission design folks what Apollo achieved, and they achieved the significant scientific examples that they got were by having a rover capability. So we need the crew to be able to to go out and get farther than than they can walk. So for me, I'd probably say some type of.
So you start with the rover. And Massimo, what would you put next? After the rover, we need.
In the past years, not only for the exploration, but we had recurring buzz about space economy. So what space and space technologies enable in terms of economy. And also, in the moon environment, we frequently hear about lunar economy. Of course, we will have an economy. And when Jim mentioned about the resource utilization, is a part of the lunar economy that we will have in the coming years. But there is a lot of science, as you said, back on the planet. So you know that one discussion and one element of a first building block that we can contribute as a country as well as a company is a pressurized model for a kind of science.
Sure, I expected that from you. Yeah.
Science lab. And of course, let's say looking to the multiple locations that we have on the South Pole means that, well, why not? We can imagine a network of those labs where we can go to make the science that you sketched now. So, and of course, the mobility is also another element. But at this stage, as you know, and we are discussing the architecture with Jim team and NASA team, that could be a contribution for the first building blocks. A couple of astronauts, if we are capable to do a little bit bigger model, 3 astronauts, 3 researchers.
So as a company, we would like to provide more than just a building block. That's clear from your answer.
Yeah. I mean,
So habitat plus
yes, an habitat and
a plan for in-situ resource utilization plus what, Dave?
Well, I assume we have the Lunar Communications Network there already.
Okay.
I think that's infrastructure we all depend on all the time, all the way. I think the energy piece is a really interesting one. So power in some way or other. So is it, what's the combination of radioisotope sources, nuclear sources, solar arrays on the ground? How about solar array satellites in orbit beaming power down to the South Polar
Sounds
region?
interesting.
It's a technology which we might need back here on Earth. Maybe it's something we can demonstrate on a very small scale at the moon. And then plea for science. I still want to see the lunar far side low-frequency radio telescope looking back to the cosmic dark ages.
Perfect. And Lisa, what would you like to add to this open infrastructure?
Yeah, I think we need power, as you mentioned. I would add to that nuclear power, some mechanism that doesn't count on the sun for some of the times when the moon is shaded, and some way of storage for that. I think in situ utilization, being able to use the resources that are on the moon and then use them to build things there, as opposed to having to bring everything from Earth to the moon going forward. And then my last and favorite thing is some sort of entertainment. Like, what are we going to do while we're up there?
So what, a cinema or?
Yeah, I think we could make our own TikTok videos or something along that.
Tennis field. Okay, this is innovative for sure.
But I would really like to build. One of the reasons for having a powerful communication system is to give everyone the possibility to participate. The virtual telepresence.
That's very important.
For us, if not in real time, at least near real time, to participate, to see what the astronauts are seeing. And maybe to feel what they're feeling. All of this is not beyond the bounds of possibility if you've got the right bandwidth to make it happen.
Yeah.
See, that could be our entertainment.
Yep.
Yeah. Nice.
Sell tickets.
We are building even, new ideas. Lovely. Now I would like to touch upon the complementarity of new players. In the last, I would say, 10 years, we saw different entities joining the Lunar Fanatic Club, non-space companies providing their technology. So Massimo, do you believe that we are going to see in the next few years an emerging lunar economy around the fact that there are different players? So why they are stepping in? I think that it is because they see a potential business. What do you think?
I think that also in this respect we have a path which is coming from the low Earth orbit to the lunar environment. Why I say that? Because the emergence of post-ISS commercial space station is also fueled by the non-space activities, what we can do not only at the research level, but applied research, and why not made in space? New materials, why not food research, those kind of things. So it's a fact that if in the coming years we start to have takeoff of this non-space field of application of our space infrastructure, no reason why that will not go to the lunar economy, first. Second, if the idea is to leave it to work on the planet in, let's say, quasi-continuous way, of course, we need a number of elements that are usual in our daily life. And they mentioned about power. I mean, you know, for instance, we signed an agreement with the big utilities, energy utilities, because at a certain point we will need to generate power and to distribute that, and we need to learn what is already at stake on the Earth. I mean, the mobility itself. So I think that it will be really a kind of lab of space and non-space, and for sure that will enlarge the number of players on top of who will build the infrastructure that will work and will pump ideas on this very new and amazing new environment.
And also the complementarity between big players and new emerging companies.
I think that this is already in place. I mean, it's not only for the lunar infrastructure. We know that today, let's say in our supply chain, it's full of small, medium enterprises with having the right technologies. I think that ESA is doing a great job in this respect. I think that we're pushing also to help those highly innovative small, medium enterprises and even startups to be part of this game. Then, of course, you know, I always said to my friends, when the first time that I came in a quite famous startup in US, I said, okay, I'm guilty, I'm an old space guy. I mean, next year I will be 40 years in this domain. Then space is space. Then you need to be reliable. You need to put on table technologies that are the right level of maturity, because when we are going to design and realize those kind of infrastructure, okay, failure is not an option, let's put it this way.
No, may happen, but it shouldn't be a dramatical problem. Let's move to, you touch upon game-changing technologies. Let's share with us what you have in mind. Which type of new technologies might speed up a little bit our moon agenda, let's say?
I think we've talked about many of them, but I'll just add to what's already been said then. I think artificial intelligence and machine learning is another area. As we spend time away from Earth and go even farther than the moon, right? Astronauts are going to have to learn, leverage. They have to be self-sufficient. They aren't going to be able to just phone home and say, Houston, we have a problem. So being able to have things like digital twins of their spacecraft that they're flying in, or systems that they're using, being able to ask a digital assistant like an Alexa, something we're going to demonstrate on Artemis 1, what is the next step in this procedure, so I could be operating with two hands on whatever I'm doing and not have to have a tech manual in front of me, and or wear special goggles for that, or being able to say what does the what does the computer system say in this particular area, and being able to quiz that, or what's next in this that I should be looking at. So I think that's the type of technology that can help us when we start thinking about some of these communication networks, being able to process some of that on the edge, and being able to do automated processing for things, intending things so you don't have to have humans there in the loop all the time, and keeping maybe even experiments going that way. So
super. So even not only artificial intelligence, but maybe even robotic support and automation, Dave.
Yeah, it's exactly what I was going to say, actually.
Okay. That was not prepared, I promise.
Well, you know all the answers anyway.
No.
The interaction between humans and robots is very interesting. We're not going to have enough humans there to do everything that needs to be done. So using the best of robotics and artificial intelligence as supporters to the human explorers is something I think we need to do a lot more about. And then on the other flip side is we will have human explorers there, but they are going to be days away. And when we go to Mars, they're going to be months away. So all the issues about crew support, medical issues, are we going, psychological aspects, practical aspects, are we going to train our astronauts to do emergency interventions if necessary? How are we going to give them the capability to do that in the worst case scenario? So there's a whole bunch of real world issues about that kind of support. I think the game changers, we mentioned space resources, it goes in the sequence. You need a lot of power to do anything with space resources. So we're doing the research about how we might use space resources, but until the power is there, it's not going to be a very practical thing to think about. But all those issues about really large capability launchers, really large capability transportation systems, that reusability to really drive down the cost of transportation is fundamental, because 90% of the costs of moon exploration is transportation.
Also the capability to handle spares.
Yeah.
In case of,
Yeah.
when you need to repair something, you will need some sort of local capability, no?
Yeah, 3D manufacturing using the regolith is probably the first thing we'll do in space resources.
Yeah. Super. Thank you. Well, we heard many times this word sustainability. So, Jim, which is the way you, how can I say, apply this word to lunar exploration? What shall we not forget in our plans to make it sustainable? Is it going to be social benefit? Is it going to be economy development, humankind push, what?
Yes.
The last
more
one.
than that, okay?
All of them.
No, I think it's some of all of them. We and I know there's folks in the audience from the NASA side that have spent a lot of time actually trying to write the definition of what that means.
Yeah.
I think we've talked about it in terms of we want a environment on the moon that is sustainable for our missions. I talked about those, trying to get to 30 days on the surface with 4 crew. That doesn't mean that's all we want to stay. If there's opportunity to stay more. But what are we bringing to the table by what we're defining with our objectives? If it's infrastructure, we need an infrastructure to do our mission. So can someone else benefit from that infrastructure? And while they're using that infrastructure, are they building something else that we can use? So it kind of, sustainability in terms of it feeds off itself for a lot of people to use the tools outside of there. Some of it is, I talked about earlier, the political side of it for us. Some of it is that sustainability, that resilience to survive beyond.
A future perspective.
Yes,
no?
and that comes from actually delivering on our missions. And delivering on the systems that we build. So for me, it's keeping that sustainability to allow us to do what we need to do long term, but not just do it alone. So how can we really provide things that other folks need, and when other countries, other companies
so it's a projection.
build things, exactly, then we can take advantage of it too.
Massimo, would you like to complement what just said?
I think that in terms of infrastructure per se, we need to design to build infrastructure that may be maintained, scalable. I mean, sustainable in the sense that, it's not just few elements, it's an architecture. And you will have over the life cycle to building this infrastructure, maybe 20, 30 years, decades. You need to really to manage what we're going to put on the planet, which is, by the way, a constant
so the logistics
over the life cycle. So I think that, first of all, it would be extremely important to design infrastructure that are, let's say, sustainable in the engineering principle. That would be easy to maintain, and to be, why not, to be upgraded.
Yeah.
So I think this is, industrial-wise, it's an important element. And second, I think that both Lisa and Dave touched that. I think that use of digital technologies at different layers will be extremely important. It's extremely important, let's say, to model the reality that we are going to live there, to have digital twins, to make simulations. But it's also extremely important to make sustainable in the sense that, that they've sketched this point, the cooperation between the man and the machines. Mm-hmm. I really think that this is a key element to have a sustainable long vision infrastructures.
Yeah.
We cannot build that kind of environment if we do not have an effective cooperation between man and machine. Machines that will change over time, will be more cognitive machine, more AI-based. So I think this is still technology-wise, but it's in my mind is a principle of sustainability of what we are going to put in the moon in the coming decades.
Thank you. While we are talking about developing a sustainable infrastructure, can I please ask each of you, but really each of us, to close our eyes? Everybody, please. I know that may seem stupid, but you know, for people that know me, everybody, not cheating. I'm checking, Jim, you're looking at me. My boss wants to, yeah, I will lose my place. Doesn't matter, everybody, including me. Jim, starting from you. Now we are going to build here with our imagination. We envision a moon base. What do you see, really, honestly, on the lunar surface, let's say in few years from now, and I mean 2, 3, 4 years from now? What is there?
Yeah, I guess, do I have to keep my eyes closed when I answer?
Keep your eyes closed and try to imagine we are envisioning this lunar infrastructure.
Trying to get the rules. I think for me, 2 to 3 years, I don't really have to even think hard about it. I think we have our uncrewed lander demo. You know, we're not far from having our crewed lander demo down there. We have a bunch of clips, payloads down there. So for me, 2 to 3, 5 years, you know.
This is a sort of promise, eh? NASA is saying, I'm promising you all that
wasn't it, but now I'm
in
opening
3,
my eyes.
4, 5 years.
Now you're changing the rules.
Okay, no.
Imagining.
Go freely. We like it. We need it. Go.
No, and I think, you know, 5 years, we're looking at our crewed lander down there, and we're on our way at that point.
Thank you. And Massimo, let's say in 10 years, what do you see on the lunar surface? Close your eyes.
No, this is what we agreed 10 years. I think that it was 20 years or 25 years.
No, you were 10.
Years. Because
The
I'm
20
not
is
sure
on
that,
this side.
I'm not sure that in 10 years what I'm going to say is going to happen. But, you know, we
10
said
years?
Just let sta zitta un attimo. I think that we already touched this point. We cannot bring everything from Earth. So I see the base and I see a place where we grow also plants, vegetables, those kind of things. No, because
in 10 years.
I mean, yeah, why not? I mean, to have our pressurized models where we build those kind of things. And of course, looking a little bit more ahead of that, you know, I was with my friend Franco Malerba, the first Italian astronaut that is thinking about how to grow plants. And okay, I need to have the places for a few wine bottles. So a wine cellar. It's inspirational enough.
I buy that scenario. It's very inspirational. Lisa, close your eyes. 15 years. 15 years.
Okay, it's 15 years from now. We have humans and robots working together on the surface. They stay there permanently. We have worked to take the water, the frozen water that's on the surface of the moon, and drill it. We've converted it so we can get oxygen, we can get liquid hydrogen and fuel, and we're starting to think about how we can use that to go farther into our solar system, and we're starting to put in place the pieces to make us sustainable, Earth independent on the moon and beyond.
Super. And now, Dave.
I shut my eyes.
You wanted to be the last one because you really wanted to share with you what you see on the moon in 20 years from now.
So Moonbase Alpha is established.
Yeah.
There are representatives of every continent of this planet, in all respects representative of humanity working together. And above them, the first human Mars expedition mission has been assembled and is about to depart for the red planet.
Thank you. Thank you very much. So I promise that this would have been a different type of discussion. I hope that we reach out, each of you, with I wouldn't call them intentions, because they are really real plans for both space agencies and industry to contribute to the development of this lunar surface infrastructure. And if any of you wish to add a comment, ask a question, we have still 5 minutes to go. So, okay. I shall be able to use this, but I prefer direct questions. Yeah. We didn't talk about?
Preparing the exploration of Mars, and we didn't talk about planetary protection policies.
It's true, because the focus was on lunar infrastructure, but yeah, there was, Lisa mentioned that for sure, moon per se doesn't make sense if it's not pointing to prepare. And I imagine, Lisa, would you like to add Mars in the picture?
Sure. I think a lot of the technologies that we will develop for the moon, the infrastructure there is good practice for what we would require to go on to Mars. I think Jim may have mentioned it. One of the things that I think we have to challenge ourselves to do is the moon may be closer to Earth and the communication lag may not be as hard. But when we go on to Mars, we need to really practice what it's like for them to be self-sufficient and not have that reach back to home as quickly as possible. And so I think some of the technologies are, how do they make themselves more self-sufficient? We talked about logistics. We can't bring all the logistics you're going to need for a Mars mission with you. So how can we create what's needed to fix spacecraft, to help with medical issues or things that are there? I think we have to practice all of that on the moon as a part of what we do.
If I may say, Maria Antonietta, just stop qua. Just a few seconds. I'm sure that David, Jim may comment, but we addressed that, let's say, what we're going to realize on the moon is a kind of living lab for exploration. So we will learn how to work in this environment, and also if we know that the Mars environment is different, but I'm sure that a lot of the technologies, a lot what we said, there will be an extremely important learning phase to prepare the next phase, yes. including starting, why not, from a place which is not held.
The learning on the people behavior. We have a question there, yeah? Just shout.
So, what is, in your opinion, the maximal settlement size that can be supplied with the current infrastructures that are being developed or are in the first phase of development right now?
Go ahead, Dave.
I'm not developing the transportation architecture. So
You're developing a lander?
So we need a fully reusable architecture eventually, and then the sky is the limit.
Yeah, I can't answer better than that. I mean, to maximize it, it's all about logistics or living off the land. And right now, we understand the limitations of what it takes. I talked about 2 crew and 4 crew for 30 days eventually. I think we understand notionally what that takes to supply them, and it's significant. So we need to find a way to solve that problem. And it's either what's there or what you bring or some balance of both to maximize the settlement.
Yeah, and I need to close the conversation, but I don't like to close with limit. I think that, especially for people as young as you are, we shouldn't give ourselves any limit. We should be cautious, realistic, but open to whatever the future is bringing us. And for sure, the technology are developing so fast, so we cannot imagine a barrier. It's more an internal push, an internal will that will bring us wherever, just to the moon to start and Mars to follow, and who knows. And with that, thanks for sharing this conversation with us, and I hope that we contributed to, building together a future for lunar exploration. Bye.
Bye.